My new studio, Mandic Labs 2.0, is missing a crucial detail. Random, pulsating, lit up power conduits running along the wall. When I got this space, when I first envisioned it, I pictured a starship with a cyberpunk, mad scientist lab twist to it. Instead, as of right now, I've got a pretty boring, gray-walled warehouse. Okay, that's not entirely fair. There is my Prusa print farm, which is not only a tool that will build the rest of my projects, but also has a great aesthetic look with an industrial flair to it. But it is lacking in a key way. Big power conduit snaking along the wall, feeding power into it like it's a reactor core at the heart of this space. So of course, in comes a pile of 3D printed parts to turn my warehouse drab into sci-fi chic. At least this backdrop behind me here. The rest of the space will come in time, and there are a lot of big projects down the road to make that happen. This is definitely the first step in a long journey. Helping us along that path is studio sponsor Prusa Research, whose 3D printers and materials make projects like this possible. And especially this video sponsor in particular, PCBWay, who offer CNC machining, 3D printing, laser cutting, and PCB manufacturing services for your projects and businesses. More on how they're playing an integral part in this project later on. I want to start off by showing you folks some of the design intricacies and failures of design that went into this project before we get to installing things. In all seriousness, I want that sci-fi vibe for my studio. I don't want it to just be a boring workshop space. I want to build fun and exciting things. And I want the space to be inspiring in that way. Most starships in sci-fi and cyberpunk, they have random LEDs and greebles and things stuck all over the place, and I do want my studio somewhat to look that way, starting with these LED strips. Ruby sketched up this concept of what we're going for. A pretty basic large strip running down the one wall, ending into a TV, and then expanding out the other side going to the print farm, as in power conduit, sending power to the farm. I took that concept and designed out a full setup using the 3D model of my studio that I've created. This is one of numerous times I've been thrilled with the fact that I took the time to create a 3D model of my studio early on. It's not 100% accurate, but it gets me really close and really helps with designing projects like this. Now, of course, I needed to split my design into printable parts, so it is broken up into sections that will be printed individually. If you look at it from a side profile, effectively what I've created is my own extrusions. They are materially efficient, as well as having cable channels for power and signal to my LEDs, and they also have mounting holes in the face of the intersection. There's a lot more going on with this shape that'll make more sense when we're assembling them, so I'll show you that later. But there are interlocking little overlap points to guide the two pieces next to each other together and prevent light bleed between them, which is something I failed on the first design with. A project with this scope was always going to take a long time to print and use a fair amount of material. But when I first had the idea for this project, I had a thought about how to cut down on both of those issues. And that was to print my entire design in vase mode. For anybody who's not familiar, vase mode is where your print head never stops moving and never stops pushing plastic in one extrusion width. There's a path from the beginning of your print all the way to the end of it that is continuous, uninterrupted. So it prints faster. Because it only uses one extrusion width, it uses less material typically as well. But that's part of the problem. There's trade-offs with vase mode. They're not as strong, though I was able to get around that somewhat. Like, I'm actually putting some force into this and I'm not breaking it, and it's one extrusion width. You see, I loaded up my machines with E3D high flow Nextruder nozzles in a 0.8mm size. So I could push 1mm extrusion widths to print 2mm thick walls in sections of this design. The plastic I chose for this project is Prusa PETG Urban Gray color, and that has excellent layer adhesion properties. The layers laying on top of each other bond together really well. The problem is material stress and warping. The design of this part, when you got one layer extrude and then it comes around and lays the next layer right next to it, creates a lot of internal stress as they cool at different rates. It also meant that my parts wanted to lift off of the bed just a little bit. And even a tiny bit was going to ruin this project, because as these are vase mode printed, they have to butt up against each other and there's no extra material to create a lip that interlocks between them. So getting light bleed between my printed parts was basically a given, and it really would have ruined the look. So I had to ditch those parts. Many may wonder why I just spent so long talking about a failed design that I'm not going to use in this final project. The answer is science. Not every experiment ends in success, but that doesn't mean that it fails. I learned that this particular application, this large scale, this size, and specific geometry just isn't going to work in the way that I want, printing it in vase mode. So I took that and I created the design I'm actually going to use with interlocking bits that'll prevent light bleed between them. Yes, they're going to take longer to print and more material, but I can load up filament on my Prusa print farm and get these parts running now. I'm running all 10 of my machines so I can get powering through this and get this project done. That includes the core ones, the Mark IVs, and the Prusa XL. There are a total of 35 prints in this project, averaging somewhere between 2 to 3 hours. The smaller ones are right around 2 hours, bigger ones around 3. I'm guesstimating, but it's a little under 100 hours of print time total for the parts I'm going to use in this project. As far as filament usage is concerned, with my precision measuring instruments, a shipping scale, and a cardboard box, I can determine that these are weighing in at 5.48 kilograms, not including the waste from the failed vase mode tests. Now, with all the parts printed, it's time to move all of this stuff out of the way so we can get to work, because I got to go from there all the way over to there. Don't fall. Clearing this corner out is just part of the prep I need to do before we get to installing the power conduits. Obviously, I need space to work, but I also need somewhere to install the power conduit onto. So blue painter's tape and laser level will help me to lay out this wall a little bit so that I can then install plywood that I painted up last week during a heat wave so that it can be blended into the wall and give me a mounting surface that I can screw anywhere I want for upcoming projects. A ledger board will help me, since I work solo, to install this myself and not have to worry about it falling while I'm getting it set up right where I need it to be, and then I can set the second sheet on top of the first. This area of plywood on the wall is 10 feet wide by 8 feet tall, and a little touch-up of paint on it to cover up where the screws went into the studs will let me have my mounting surface. I need a conduit run through this area for networking and display cables and other stuff that's going to be coming down the road, but it needs an offset. Commercial offsets just aren't big enough, so a liberal application of heat to this PVC conduit and a little brute force, I can create my own offset to the size that I need. I think I kind of got lucky and nailed it pretty well on my first go. It's not the prettiest thing in the world, but for this application, it's just fine, and it's going to get around this metal structure at the top of this wall how I need. I designed up a couple of 3D printed clamp mounts for it to go directly into the corner, one going into the concrete wall on the left and the other into the plywood on the right. With the second clamp installed on the conduit in the corner, it is securely in place and ready to do its job. The plywood is up on here and really solid. From up close, you can really see the grain of it, you can see the edges of it, but I think even just a few feet stepped back, it blends into this wall really nicely, which is exactly what I was hoping for, and it's going to serve its purpose really well. That's going to be a whole nother project down the road, but let's just say this whole thing is going to be covered not too distant future. Now it's time to start covering it with our power conduits. Then I quickly noticed the big hole in my plan, the TV that dictates where the conduits are running through. I need to get this mounted to the concrete so I know where everything's gonna be. This is going to serve the purpose of being my logo display in my background, as well as maybe used during live streams, and some future uses we'll talk about down the road. Once it's in position, I know where everything's going to be, so I'm going to start with what I think is the most important piece, this corner that bridges over the conduit coming down the wall. I cut a couple of holes into that 3-inch conduit so cables can pass into our LED housings from the back where they won't be visible outside. From there, it's just a matter of solving the big puzzle I created without labeling any of the larger pieces. I had to keep cross-checking these against the CAD model so I could figure it out. I did get it done. Then I learned my lesson, and on the smaller ones, I numbered them so they were way easier to install. What was also way easier was installing the pieces onto the plywood. This is so much nicer than having to drill into concrete for every single screw. The smaller conduits go from the TV over to the print farm shelves and line up with those shelves so that the LEDs can flow smoothly through the conduits and then through the shelves. The larger and smaller conduit pieces were all designed around the same depth to keep things uniform. That depth was dictated by having to fit behind this upright post that I knew I was going to have to work around. And eventually, we reached the end, which is actually the beginning. That'll make more sense when we get to wiring in a second. And with that final piece in place, we are almost done installing these. I'm going to move on to wiring up the LEDs, as that's going to be a time-consuming portion of this. There is one little section over here that's missing. It's currently printing because it was actually 36 printed parts, not 35. I miscounted. Before we get to installing the actual LEDs in here, we need power. That's where this old Ender 3 power supply comes in. I decided to go with 24 volt LEDs in this application for better voltage drop along the long run, and originally the idea was to go even further down the wall. I decided against that and dialed back the scope a little bit, but I still think 24 volts is going to be the right choice here, and I have a pile of 24 volt power supplies, so let's get this one set up and installed. I just used one of the fan mounting screws to screw on this small 5 volt 15 watt buck converter that steps down 24 volts to 5 volts. That should run pretty cool with the fan blowing across it. It was just convenient to do. This is for our control board. This little PCB is YAWL, yet another WLED controller. A compact LED driver board that I've used on multiple projects lately, produced for me by the folks at PCBWay. Studio sponsor and sponsor of this video in particular. This tiny but mighty board has a lot going for it. It is an open source design, so you can get all the files to produce this thing for yourself, play around with it, change it up if you want to. It has inbuilt circuit protection with a fused input, reverse polarity protection, capacitor right on here for smooth animation adjustment from one setting to another. It runs an ESP32 chip, a very widely adopted platform with Wi-Fi connectivity for remote wireless control. That control is handled through WLED, the open source RGB control firmware that I've been using on a bunch of projects lately that allows for a ton of adjustability. Whether you're using something like the 24 volt LEDs I'm using here, the 5 volt LEDs that I used on my print farm, you have a lot of options for different LED chips and animation styles and so many settings to play with. This little PCB unlocks all of that in a compact package, and you can get it from PCBWay for yourself. I got it off of their projects page. They have a ton of projects available that you can pick and choose from on their platform, so you don't have to know schematics and designing PCBs. You can find something that might fit your needs for your project or somebody else's project that you like, and you can take parts from listed on that platform, provide those files back to PCBWay, and have these produced for yourself or whatever else you might need. Whether it be 3D printing services, CNC machining, laser cutting, or PCB manufacturing, PCBWay has a lot of options for your hobbyist projects on up to your business production needs. Please do consider checking out the link to PCBWay in the description and the link to this project in particular if you're interested in it. It really shows them that you appreciate the support that they're giving to Mandic Labs 2.0. Let's get this little board wired up, set up, and get our LEDs in this. I printed up a basic mount for the YAWL board on the Prusa Mark IV, and I'm honestly just going to go ahead and double side tape it to this power supply housing. It's going onto plastic. I'm really not worried about it. It's going to be in an area where nothing is going to be able to touch it, so it should not be an issue. We still need a power cable to our LEDs, but I'm gonna install that after I get this in position, so this looks like a suspicious package one would report at the airport. Let's get it installed. As far as mounting my power supply and my control board and all that, I'm using gravity. I'm just gonna set it up in this channel here. There's no moisture up here, it's just dusty. I cleaned it earlier. I know this is grounded. Gravity's gonna hold it in place. It's fine, I'll just need to dust once in a while, which realistically I should be doing anyway. But I do wanna have a nice long cable so I can reach the receptacle for the lights that's over there, and I can reduce the length of the wire, feeding my LEDs out of the power supply. I'm calling an audible on the field here. I'm going to install this fuse block in line after the power supply before the LEDs. That way I have a power distribution point so I can jump off of. I want to make sure I get good power feed to all of my LED strips so they're nice and bright. This will also allow me, of course, to circuit protect with fuses too. So it'll make my life easier and safer. I was unable to locate any heavier gauge wire, so I just tripled up some 18 gauge to feed that fuse block. Now it really looks concerning, and like I should have made a whole mount setup for this. Whatever, you're never gonna see it. With our power hub and our control circuit in place, it's time to start running some LEDs. I'm using these 24 volt, as I said, RGB LEDs, WS2811, I believe is the driver chips on these. Anybody's ever installed these types of LED strips, you probably know that the glue, the adhesive that's on them is lackluster at best. As such, I'm peeling off the backing on their own double-sided tape and applying VHB tape. I find that that adheres to the glue on the double-sided tape of the LED strip decently, better than they do to other things, and then hopefully that should adhere pretty well to my prints. PETG is pretty slick, so only time will tell. The install process is a lot of peel, stick, and repeat ad nauseum, so I'm not going to subject you to that full process. I do have to pre-tin some of the solder points and wire on a couple of wires outside of the conduits because it's just easier, but the power cables need to be in very specific locations, so I did those in place. Not fun, but doable, soldering these tiny pads inside of here. The larger conduits, I left room for 2 LED strips to really fill this with light and just make it a little brighter. I'm also going to be lining the entire inside with foil tape to help with reflection and increase light output. It's also going to help me hide some of my data wires rather than pull them through the channels. This side electrically is wired, that side isn't, but that means we can test this side. So let's get to it. It's probably going to require a config, but I'm going to flip the switch and see what happens. All right, about to start. Progress. We got color. With that win under our belts, it's on to the smaller other side channels. These are harder for me to get the camera in here and film while working, so we'll move on. With the LEDs and foil tape now installed in both sides of the conduits, I need to bring the two of them together. Currently, they are 2 completely separated sections that need to meet in the middle. For right now, I grabbed some of this Prushiment PETG V0. This is great for electronics housings, or what I'm going to use it for is a junction block. It's self-extinguishing PETG, so if some odd reason it was to ever catch fire, it would put itself out. I used it to print up this junction block, which just is some M3 screws and heat inserts into this plastic body that'll isolate these 2 separate terminals from each other. I can use that as a junction point for my wiring. I also printed up a handful of these little cable organizers. I'm going to use those with some VHB tape attached to the wall so I can zip tie these wires and cable manage a little bit. And since some of the wires will be visible when this is all done, a little bit of sleeving is going to help to tidy things up. And with that, wiring is complete. TV's back in position. The foil tape's all in. It means it's time to fire this up. I think it looks pretty darn good, but there are some glaring issues here. There's a lot of LED hotspots. You can see individual LED chips inside of there. The reflectiveness of the foil and the unevenness of it doesn't look great. We need some diffusion on this situation to make this more of a uniform lighting setup that's not so ugly when they're not in use. So I raided your grandma's dining room. I had a heck of a time deciding what diffusion material to use for this project. Originally, I was thinking of 3D printing them of clear PETG, but that's a lot of really thin prints and a very tall height to get them as few pieces as possible. It would have gone badly. Diffusion fabric for studio lights, it's got no structure to it. Acrylic I can get, but it was going to be costly to get good diffusion acrylic that wouldn't lose a bunch of light coming through it, chipped in. So what I landed on is your grandma's plastic dining table cover. It's got that little bit of texture on one side, smooth finish on the other side. I'm hoping it's going to be a pretty decent diffuser. I just have to cut it to fit. To cut this, I'm not going to use my track saw, but I am going to use my track saw track as it's the longest, decently straight edge I have quickly available. What I am going to use is a utility knife. Pretty sure this should cut pretty easily with this. Just guide it along this extrusion. Oh yeah. Now my design specifically has a groove that was always intended to accept this material into it. I just need to fit it in. Fit, feed, I was trying to say both, whatever. This is more rigid than the fabric stuff, but not by a lot. Oh, this is not working. This isn't working. It's too see-through, it's too floppy still. Thought I had a bright idea. It's not working. I think I have a good size now of what I need. I'll have to figure that out for over here. So I'll use this as a template, and then I'm just gonna have to bite the bullet and spend way too much money on diffuser acrylic. I think there's a place in Portland that I can get it cut custom. I'm just gonna have to do it. Some important notes of final details. There's a gap between the TV and these conduits on this side and on that side actually. That's not going to be the case in the end. This TV is temporary. It's just what I have. Can't really afford the TV that's going to live here right now, but it's going to be a little bit larger than this and it will overlap these just a little bit. So the ends of those will disappear into the TV. Oh, and one more thing. This TV, not only being temporary because of the size and the shiny screen, I need something with a matte screen. It's also broked. It didn't survive the move from the last studio to this studio, unfortunately. Got damaged, just packed it the same way I did when I moved cross country, but it didn't make it here. So let's just pretend my logo's up there for now. Overall, I'm loving the way this is coming together, but there's still an issue. These are addressable RGB, which mean they can be animated, but they're not properly animating currently. If you know RGB stuff, you probably already know what the issue is. I mentioned earlier about the wiring here. The way addressable RGB works is you have a data wire that tells each LED what to do when animating or changing colors. My wiring starts over here for the data line, and it travels all the way down here, behind the TV, and into these branches on this side. There are actually two data lines. You can only wire data lines in series, not in parallel. So when it splits off at the Ys over here, it has to run through one and then come back and then go through another one. It doesn't really work out that way. So I spent an embarrassing number of hours with Gene and I working, going back and forth with ChatGPT, trying to figure out how to map these LEDs, which can be done in WLED. And I finally got it figured out. And I have what's not perfect, but a much better mapping that gets me the animation that I want, running all the way from one end to the other and even through the printer rack. This is definitely not perfect. Without the diffusers on there, we're losing a lot of the effect, unfortunately, but I just do not have the time. I looked, I can get a place in the city to cut it for me, but it's gonna be 2 to 3 days and I need to get this video up and on to the next project. So we've got what we've got, but I still think it looks excellent, and I think you can really get the feel for the vibe I'm aiming for with Mandic Labs 2.0, now that we're making some actual aesthetic steps. Could this project have gone better? Absolutely. Between the one design I had to scrap, the diffusers that didn't work, there were definitely mistakes made here, but honestly, I'm thrilled with the way it's turning out, and it's getting me excited for more projects. So maybe I'll cover this finished in another video, or maybe just behind the scenes on Patreon, but we definitely have some more and hopefully better thought out aesthetic projects coming up in the near future in Mandic Labs 2.0. All right, I hope my vision is in your head. You can imagine, you can see it, and maybe it gives you some creative spark and ideas for your space. Hope you found this video interesting. If you did, please do drop it a like. Let me know in the comments. What would you have done differently? Do you have a better diffuser material for me? Let me know what you're thinking in the comments down below, and get subscribed to ensure your 3D prints don't fail. It's not a guarantee, but it can't hurt. See you, folks.